Hi guys. Um, with this, these types of problems, right? We're gonna be writing them in simplest form, and if you look at it, you see that we have a radical in the denominator, right? Now, technically, we're not supposed to have radicals in the denominator. There's some dead math guy who was being anal and didn't like it. All right, if it was up to me, that would be a perfectly acceptable answer, but it's not up to me. And so we have to do something to get rid of that um, that radical in the denominator. Okay, so what we're gonna do, and it's not tough. What we're gonna do is we're gonna multiply by what they call a conjugate. Okay, so we're gonna multiply by what they call a conjugate. Now you guys know I can never spell. All right, sorry, that's supposed to be a J. So this conjugate. All we're gonna do is we're gonna look at the denominator. All right, we're looking at that denominator, but more specifically, we're looking at the sign. All right, and all a conjugate is I look at the denominator and I change the sign. So it was a positive, now I'm going to change it to a minus. That's all we do. And I'm going to do the same thing in the denominator. All right, now if you really think about this whole thing here, if you really think about it, it's just one. All right, so I'm not changing anything. So think about anytime you multiply something by one, it doesn't get changed. All right, the number doesn't change. All I'm going to do is I'm going to make this look different. Okay, that's all I'm going to do is I'm just going to make this problem look different. So when I multiply by the conjugate, it really equals 1. All right, so that conjugate really is just 1. Conjugate is we're changing the sign. All right, so hopefully you guys are good with that. All right, so when you multiply straight across just like you've always done. Okay, multiply straight across. Now I'm going to show every step so that I'm not screwing anybody up. So I have that 1 times 5 minus the square root of 3 all over. And then I have the 5 plus the square root of 3. I have that times the 5 minus the square root of 3. So I'm multiplying by its conjugate. All right, so now what happens when I distribute that 1? All right, nothing changes. So nothing changes. So I have 5 minus the square root of 3 over. Now, think about when you're distributing here, right? When you're distributing here, you're just doing FOIL, double distributive property, whatever it is you want to call it. Okay? That's all you're doing. So I have 5, right? So I'm going to do 5 times 5, which gives me 25. And then, sorry, I'm trying to throw some colors in here for you guys, so hopefully it'll be a little bit easier. Now I'm going to do 5 times that negative square root of 3. And when you do that, a positive times a negative is just negative. And then 5 times the square root of 3 is just 5 square root of 3. Right? You'll notice all you're doing is kind of pushing them two things together. All right. Now, I'm going to move over and I'm going to multiply 3 times 5. All right. So the square root of 3 times 5. Well, the square root of 3 times 5 is exactly the same thing. All right. Because the 5's not underneath a radical, I'm just going to put the 5 on the outside and then the 3. And then last step, I'm going to do square root of 3 times the negative square root of 3. Because both of those are underneath a radical, all right, I can multiply those together. So I had a positive and a negative, so it's going to give me negative. Square root of 3 times the square root of 3 is the square root of 9. All right, so now we look at it. The numerator, nothing changes. So 5 minus the square root of 3. And then I look at the denominator. I have I have this 25 here. All right. So I'm going to rewrite that. And then I have a negative 5 times the square root of 3 and a positive 5 times the square root of 3. And I can add those together because the square roots are exactly the same. All right. Oh, crap. Because the square root of 3 are exactly the same. All right. So I can add those together. So what happens is I'm just going to add the negative 5 and the positive 5. Think about if you were adding negative 5x plus 5x. All right, it's the same thing. It's the same exact thing. Because those square roots of 3 are exactly the same, I can add those together. Well, what ends up happening? They cancel each other out. And that's what happens when you multiply by the conjugate. All right, and then I'm left with square root of 9. All right, so I have minus the square root of 9. Well, the square root of 9 is just 3. So in the numerator, I have 5 minus the square root of 3 over, and then 25 minus 3 gives me 21. If I can learn to come on. If I can just learn to add and subtract here, guys, it'd be dangerous. All right, it's 22. And you'll notice that the denominator no longer has a square root in it. All right, the radical is gone. So this answer, this answer, and our original problem here are exactly the same. They just look different. All right, because the square root no longer is in the denominator, but they're the exact same thing. If you were to grab your calculator and type that in and get an approximate answer, the approximate answers are going to be the same for both of those. Okay? All right, let's do another one a little bit faster. If you want to pause the video, you try it, and then um, um, we can, hit play and check to see if you got the right answer. All right. So again, I can't have I can't have this the square root in the denominator, so I have to do something to get rid of it. So again, what do? Multiply by the conjugate. All right, multiply by the conjugate. And remember, all we're doing is whatever that sign is, we change it. Okay? So I have the square root of 7 plus 2. Square root of 7 plus 2. That's all we do. Just change the sign. Right? No big deal. Now multiply straight across just like we did the first time. Okay. Again, I'm not going to skip any steps just for anybody that, because I know this is you guys are still trying to get used to this whole e-learning thing. All right. And then I have the square root of 7 minus 2 times the square root of 7 plus 2. You notice that they're exactly the same except for the sign in between. Okay. So the numerator, nothing changes with the numerator. So I have the square root of 7 plus 2. Then the denominator. Square root of 7 times the square root of 7 gives me square root of 49. All right. Oh, crap. Okay. Square root of 7 times the square root of 2. Just like before. Because one's a square root, one's not, I cannot multiply them together. All right. So just kind of push them together. All right. That's all we end up with. 2 times the square root of 7. All right. Now we do negative 2 times square root of 7. So we end up with negative 2 times the square root of 7. All right, so when we multiply those two together, I wish there was an easier way to doing this, guys. But now, negative 2 times positive 2. We end up with negative 4. All right, so we multiplied everything. Again, The numerator doesn't change. Now, let's look at this denominator. Square root of 49. Square root of 49 is just 7. All right? Now, what happens? Positive 2 times the square root of 7 and a negative 2 times the square root of 7. Well, those two things, they're going to cancel each other out. All right? One's positive, one's negative. They cancel each other out. And then what am I left with? Minus 4. All right? So let me write that minus 4 down. All right. So then I end up with a square root of 7 plus 2 over 3. All right? Again, square root is gone in the denominator. And that's all I'm worried about. So we multiply by this conjugate. All right? We multiply by the conjugate, and we ended up with this. All right, last problem. A little bit uglier, but still the same thing. All right, we're going to multiply by, well, I look at that denominator. Remember, what are we doing? Whatever that sign is, just change that sign. All right, that's all we're doing. Just change that sign. So I have the square root of 6 plus the square root of 8 over the square root of 6 plus the square root of 8. Exactly. You notice they're exactly the same. Again, we can think about this whole thing right here as 1. All right, so all I'm doing is multiplying by 1. All right. Again, I don't want to skip any steps. I don't want anybody yelling at me. So multiply straight across. I have 5. Let me just do open parentheses. Times the square root of 6 plus the square root of 8. All over the square root of 6 minus the square root of 8 in parentheses times square root of 6 plus the square root of 8. Okay? And just like we've always done, all we're going to do is we're going to distribute. All right. Those other two problems, the numerator was always 1, and this one I wanted to show you a little bit something, a little bit one that's a little bit different. So you notice they're in square roots. They're all in square roots. So I can actually multiply these together. The square root of 5, the square root of 5 times the square root of 6, because they're both square roots, I get the square root of 30. All right. Now, I can do square root of 5 times the square root of 8. Because they're both in square roots, plus the square root of 40. All right, not so bad. All you're doing is just multiplying. All right. Now, denominator. All right, now this denominator. Square root of 6 times the square root of 6 gives me the square root of 36. And again, I'm hoping these me highlighting with color is helping. Square root of 6 times the square root of 8 gives me plus square root of 48. Right? 6 times 8. They're both underneath the square root. Multiply them together, leave it underneath the square root. Now, negative square root of 8 times the square root of 6 just gives me negative square root of 48. Right? Positive times a negative gives me that negative. 8 times 6 is 48. They're both underneath the square root. So I just leave it underneath the square root. All right. Negative square root of 8 times positive square root of 8. So it's negative square root of 8 times square root of 8, square root of 64. The numerator. Right now, I'm going to say we can't do anything to the numerator, but actually later on, I will show you that we can do a little something to it, okay? But for right now, we're going to leave that answer just the way it is. All right? I'm not trying to make this tougher than it has to be right now. So I look at the denominator. Starting from left to right, square root of 36 is just 6. All right. Square root of 48 minus the square root of 48. Well, you'll notice they're both 48s. They're exactly the same. What number's sitting out in front? Well, there's a 1 sitting there, there's a 1 sitting there. They're exactly the same, except for the signs are different. So these two cancel each other out. So it's gone. Do you notice that happened in every single problem? All right, it happened in all these other problems that we did. It's going to happen with you also when you're doing this. And then lastly, negative square root of 64. Well, negative square root of 64 is 8. So then my final answer, square root of 30 plus the square root of 40 over negative 2. Okay? Again, we actually can do something to this, but for right now, I just want to leave it like this. I don't want to make it tougher than it has to be. I just want you guys to practice these types of problems. All right, guys, please make sure you ask questions.